Welcome to today's deep dive, where our mission is to decode the hidden complexity of professional AV infrastructure. And today, we're looking at something you might just trip over in a server room.
Right. I mean, it usually just looks like a heavy-duty black cord.
Yeah, exactly.
Yeah.
Specifically, our source today is a product spec page from HDTVSupply for the DVIGear DVI-2360-FOD Optical Plenum cable. It is a 60-meter cord, but the invoice reads $645.
Which, to the untrained eye seems completely absurd for a single cable.
Right, like why does one cable cost as much as a decent laptop? But we're dealing with the nervous system for high-end data centers, enterprise networks, and broadcast facilities here.
Exactly. You aren't just buying a standard copper wire. You're buying highly specialized glass and, well, absolute reliability. When we really unpack the engineering on this spec sheet, that price tag actually starts making a lot of sense.
But let's get right into the optics then. The spec sheet highlights that this is a 50125 micrometer multimode fiber.
Yeah, and for those doing heavy AV routing, multimode is pretty standard for these medium range runs, this cable being about 197 feet.
Okay, so I want to test an analogy here.
Yeah.
Is multimode fiber essentially like a multi-lane data superhighway, especially when you compare it to a standard copper cable's single-lane dirt road?
That is a great way to look at it, yeah. That the 501.2V5 measurement is the real mechanical secret there. The core, the actual glass carrying the light, is 50 micrometers thick.
Wow, that is incredibly thin.
It really is, and it's surrounded by a 125 micrometer cladding. That cladding has a slightly lower refractive index, which basically forces the light rays to constantly bounce back toward the center.
Oh, instead of just escaping out the sides.
Right, exactly. So you have multiple light rays, or modes, zigzagging down that microscopic core at the same time. It acts like a highly engineered optical hall of mirrors.
And that mechanism is what allows for massive bandwidth, right? Like pushing uncompressed data over these localized distances without signal degradation.
Precisely. But, the glass itself is only half the battle. You have to connect it.
Yeah, the source mentions 8 factory-terminated LC connectors. Lucid connectors are standard for high-density patching, sure, but the factory termination part seems huge.
Oh, it's a massive deployment advantage. Splicing fiber on-site is a nightmare. It invariably introduces microscopic misalignments.
Because you're usually, up on a ladder trying to align microscopic glass?
Exactly, yeah. And when you're pushing uncompressed 4K or 8K video streams, even a tiny fraction of a millimeter of misalignment causes severe signal attenuation.
So having 8 of them fused on at the factory means you're just plugging in a pre-aligned 8-lane optical matrix right out of the box.
Right. You get 8 distinct channels with verified signal integrity before it even leaves the manufacturer. It's foolproof.
Okay, I get the precision of the glass, but I'll push back a bit on the overall value proposition. Because standard multimode fiber can still be had for a fraction of that $645.
That is true, but you have to look at the jacket.
Right. The spec sheet makes a huge deal about it having a Plenum-rated black jacket. But doesn't a jacket just exist to keep the glass from getting scratched?
Yeah.
If I'm building an enterprise AV rack, I care about data throughput, not the specific plastic wrapped around it.
Well, the thing is, your AV rack doesn't exist in a vacuum. Fast data transfer is only half the story. Where the cable safely lives is the other half.
Okay, so why the massive premium for a CMP, like a communications multipurpose cable, Plenum rating?
Because of building safety. In commercial buildings, cables are heavily routed through plenum spaces. Those are the dropped ceilings or raised floors where the HVAC system circulates the building's environmental air.
Right, the return air spaces.
Exactly. If a standard PVC cable jacket catches fire in one of those spaces, it burns rapidly. And worse, it pumps thick, highly toxic smoke straight into the ventilation system.
Oh, wow. So a localized electrical fire in a server closet suddenly pushes poison gas into the boardroom 3 floors up.
Yes, and that is the exact life safety issue that building codes are trying to prevent.
So the Plenum rating means the jacket is legally and safely allowed in those spaces.
Right. It's extruded from special fire-retardant polymers like Teflon. It actively resists burning, and if it is exposed to extreme heat, it emits very low smoke and non-toxic fumes.
Huh. So you are paying that premium just to be legally compliant. I guess it ensures a building inspector doesn't force you to rip out miles of ceiling infrastructure.
Exactly. In enterprise tech, physical infrastructure and life safety are just completely inseparable from data performance.
That really reframes the whole spec sheet for me. That $645 isn't just for 60 meters of wire. You're paying for commercial-grade durability, high-speed multi-channel data transfer, and strict safety compliance all rolled into one.
Yeah, it's a mission-critical component.
Well, here is a thought for you to mull over as we wrap up today. The next time you're in a massive, high-tech sports bar or a modern office, look up at the ceiling.
We'll never look at it the same way again.
Right. How many invisible miles of specialized glass fibers are quietly working right above your head to keep the digital world flawlessly connected? And what happens when we reach the physical limits of how much light we can cram into those 50-micron tubes? When the ceilings can't fit any more cables, where does our hardware go next? Keep digging into the infrastructure around you, and we will see you on the next deep dive.